All right, so let's go over this, guys. So you can fill out your activity as we go through these types of neuroimaging. And I kind of want to show a few more that weren't mentioned in the book. So, real quick, this is what a CAT scan looks like. And what does a CAT scan mean? What does that mean? What is it defined as? What does that mean? What do we got, Hadley?
Computerized axial.
Yeah, good job, meaning CAT, right? Great way to break it down. And how does this imaging work?
Oh,
Yeah, go ahead. Yeah.
well, basically, there's a moving ring that passes X-ray beams around the subject's head, and then radiation is then absorbed in the amount of the brain tissue, and then the computer measures the amount of radiation that was absorbed and transfers the information to the CD.
Awesome, good job. And here's a good image of what a CAT scan looks like. As you can see, you're kind of like looking down at the brain, and it's imaging again, kind of the structure of our brain and maybe how its function looks like. And with that, you don't really see exactly like if they're showing any type of activity within the brain. Okay, like you would see in, let's say, an fMRI or a PET scan, right? This is only just seeing the surface area of the cerebral cortex. And again, it's sending X-ray images to see exactly what the top of the brain looks like. In certain cases, with people that have high impacts, or like let's say in football, professional athletes or boxers, you might see that the brain is a little bit more, like you say, the fissures and the gyri of it looks a lot harder, a lot thicker. Okay, as it took a lot of impacts and a lot of different types of, I can say, condition to it. Okay, so this is good representation of what the brain looks like from really looking down at the skull. Again, X-ray imaging, you can't really see functions of it. Like let's say someone's performing activity, you can't see what associated location or lobe of the brain is being activated when performing an activity. This is just really showing a spatial view of it. Okay. And again, like I mentioned, people that really take a lot of hits, okay, a lot of impacts to the head, you can see the brain is a little bit more, I can say, it looks like it's conditioned more. It looks like it's impacted more as it is taking a lot of activity or a lot of impacts to the brain. Okay, you guys good with CAT scan? Yeah. So again, you kind of go in that like cylinder there, and it looks like the X-ray images show an image of the brain of what the structure looks like. Again, not showing any activity, right? There's no activity there at all. But again, it's showing a good spatial view of the brain from the top down. All right, PET scan. What do we have here, Allison? What does that mean?
It's a scan used to capture the picture of the brain's activity.
Okay, good. What does it stand for?
Position and mission.
All right, yeah, so positron emission topography, good job. So this is really just looking at the brain, okay, and this is actually an injected form of, like you say, it's like almost like a radiation in a way into the brain, and it shows the activity when performing, let's say, an activity. So there might be questions being asked as these people are inside of this form of technology, form of scan, where the activity is being flowed to the brain. So a lot of times they might be listening to music. So again, with receptive language, where is that focused in? So when we're receiving information, we're receiving auditory information, where is that located? What part of the brain? It's left hemisphere, right? But Hadley, what is it? Yeah, the Wernicke's area. So we're going to see that located, mostly temporal lobe, maybe part of the parietal as well. Okay. And again, this is an emission that is being sent off as it's really impacting with the radiation within side of you as it's being projected. Some advantages to it is that you can see exactly where the activity is being performed in the brain, wherever where we might be receiving auditory information, or let's say if we're expressing language, we might be talking, right? Or if we're just thinking of different planning and judgment, it might occur in the frontal lobe. And some disadvantages that you're being injected with a radioactive substance, right? Not to the point it will kill you or anything, but again, this is just a better view of where this association, this expression is occurring in the brain, where there's signaling being fired, where neurons and synapses are occurring. Does that make sense? All right, cool. Next one, MRI scan. What do we have? What do we got here? Go ahead, Christian. Yeah, so this is just a magnetic response of it, magnetic view that's being shot into the brain that we can visualize and see the structure of the brain. Okay. And this is a better look at it. There's a lot safer than let's just say a PET scan where injecting radioactive substance into the body. This is actually seeing the structures of the brain, the lobes, and different parts. As you can see the limbic system. You can see the brainstem standing up into the cerebral cortex, and overall gives a better view of what the structures of the brain looks like. Let's say compared to a CAT scan, right? The CAT scan you only can see from the top down, right? You only can really see the cerebral cortex. But with an MRI, really sending magnetic fields into the brain, you can see a little bit more functions, more different parts of the brain. Again, not like a PET scan, no, you can't really see exactly where the activity is being focused, right? If let's say pain or emotion or any type of memory or any type of activity, expressive or receptive language, you can't really see that association, but you can actually see the parts of it a lot better. Okay. As I said, you can see the limbic system, the brainstem, parts of the cerebral cortex, depending on how far you want to actually shoot in spatial observation of the brain itself. So again, a little bit more advanced, okay, as we're seeing magnetic visions and visuals of the brain. Last one that was on your chart here, fMRI, a little bit more advanced. What we got here? Christian, what do you have here for fMRI?
Technique that provides high resolution reports of neural activity based on the symbols.
Yeah, good job. So this is really seeing the oxygen levels within the brain as it's being activated. All right. So not like the PET scan. Okay. Obviously, you can see the visuals of exactly where this activity is occurring, whether it's a lobe of the brain or let's say the limbic system or brainstem, whatever have you. But with the fMRI, this is actually just oxidated blood. Right. This is a better look at it. We're not injecting any radioactive substance within the body to be visualized in the brain from these scans. This is just how it's being activated when it's being functioned, when the blood is flowing to these different parts of the brain to activate it. So this is a really good look at it, a lot safer, obviously, than a PET scan. And you can get a good visualization of where this activity is occurring, where this is happening. Okay, does that make sense, guys? All right, one other thing I want to show you is an EEG. And this really doesn't even show any type of visualization of the brain. But the activity that is responded with it is pretty good, and it's very effective, and it's pretty fast as well of how they can send that information back. So real quick, I want to just show you an EEG, and I have a video to show you then as well about a violinist who went through brain surgery. So this is what an EEG looks like. I'm sure you've seen something like that maybe in a movie or show before, where they have little electrodes that go around the base of the skull. And this is really just picking up any type of neural activity, any type of messages being sent or delivered, let's say, from the brain to the rest of the body. So this might be an activity that's performed. Okay, this might be expressive language, it might be any type of receptive language. And these electrodes are picking up electrical signaling. So neural information being sent from synapses being connected to really, it looks like a seismograph. You guys know what a seismograph is? It detects earthquakes, okay, kind of like that, right? So this is very similar to that. As the messaging is being relayed, as it's being signaled, it triggers a seismograph look of just how much activity is occurring within your brain. And this might be applied to people that might be in a coma, right? See if they're actually receiving any information as they're going through the coma, going through this, I guess, say unconscious state. Okay, they want to see if there's actual brain activity being performed. Okay, so again, you're not getting an image of the brain, okay, like an fMRI or any type of PET scan or CAT scan. But at the same time, this is recording any type of brain activity. So neural messaging, neural signaling through these electrodes. Okay. So again, it's just triggering an almost seismograph look. So if there's any activity, none at all, if there's no questions being asked or any activity being performed, it's just going to be a straight line. And then let's say you perform an activity with an EEG, kind of electrode strapped to your head, then it's going to be triggered, and you're going to see more of a brain activity being occurred as it's being utilized. Okay, does that make sense, guys? I'm sure you guys seen a seismograph or heard of it before as I described it to you. But that's exactly what an EEG is. Again, there's no scan of the brain occurring. There's no images being presented. It's just recording brain activity on this really chart, right? This seismograph chart. You guys ever see Nightmare on Elm Street? Freddy Krueger? No? Yeah? Okay, yeah. So they kind of show an EEG in that as the child goes to sleep and he's attacking her in her dreams. They have electrodes strapped to her head, and you can see that it's being triggered, her fear, and I guess you could say emotion aggression being triggered as she's in her dream state, which I think is pretty cool. Yeah. All right. Any questions on these types of scans? Good. So neural imaging, we're all right with that? Okay. So make sure you guys study that. It's going to be on the exam, on the test. Right now, I just want to show you a video to end in class here. It is this violinist. I think it's pretty cool. He actually probed inside of his brain. He actually had a tremor where obviously if you're a violinist, you need to be particular. You need to have the motor skills, fine motor skills to obviously move the violin to play the correct sound. And he was a professional at it. And they actually wanted to try to solve this tremor that he had because he was really shaky with his violin. And they triggered within his brain and his motor cortex to allow him to be more precise, more accurate with his movements. And it's pretty cool. They actually do the brain surgery while he's playing the violin. Pretty scary to think about, right? There you have people probing into their heads. You guys ever hear Neuralink, Elon Musk? That's also something that is being talked about big right now, as he's trying to find a way to link different activities from the brain, or maybe calling someone on a device just by thinking of it, or communicating with someone with just by thinking of it. You don't have to actually express it, which is pretty amazing when you're thinking about that type of technology and what's being used in today's world. So check out Neuralink on your own. It's pretty neat, pretty cool stuff.